So transition metals are these metals which we can find in the center of the periodic table. So the most important ones that you need to know, and they will probably come at different stages in your specifications, are chromium, manganese, iron, Fe, cobalt, nickel, Ni, copper, silver, Ag, and gold, Au. So these are some of the transition metals, and we're going to talk about their properties and the uses of some of these transition metals. So they are metals. Transition metals are still metals. They have the typical properties of a metal, but they also, in addition to the typical properties like being good conductors of heat and electricity, being dense, strong, and shiny, they also have their some special properties. So the first thing is that transition metal can have more than one ion. So when you look at the typical metals like group 1 elements, you're going to find that group 1 elements will only form one ion, which is +1 or +1 um, ions, like sodium. Sodium will always find this sodium plus, lithium Li always one ion which is plus, but for the transition metal they can form different ions. Examples of that are the copper. So copper can give you copper plus or copper 2 plus. So two different ions. Cobalt, you could have CO2 plus or CO3 plus. Iron as well, you could have Fe2 plus or Fe3 plus. So they have the ability to form different ions. Another property for the transition metal is that their compounds will form usually the metal ions are colored, so the compounds which contain these ions are colorful. So the ions themselves are colored, so any compound that have these metals mostly tend to be colorful. Some examples are potassium chromate, which is yellow, potassium manganate, which is purple. Transition metal compounds themselves can make good catalysts. Not all of them, but some of them can make good catalysts. A catalyst is a substance that tends to fasten a reaction or speed up a reaction without being used in that reaction. Some examples of these are the nickel-based catalyst, which is used in the hydrogenation of alkene, and iron catalysts, which is used in the Haber process to make ammonia. Both of these reactions, we are going to talk about them later in the specification as well. Compared to group 1 elements, transition metals are less reactive. Less reactive to the extent that some of them are completely unreactive with air and with water. So if we remember, group 1 elements tend to react fast, quickly with air and to give oxides, and with water to give hydroxide and hydrogen. But the transition metals, some of them don't react at all with air and with water. They also tend to have much higher melting points. For example, manganese, one of the transition metal ions, melts at 2000 degrees, and while sodium, for example, melts at 98 degrees. So because they have very specific or very um, specific properties that are special to them, they tend to have wide variety of uses or many uses, wide range of uses. Their properties are similar, but they are not identical. So it's important to choose the right transition metal for the required purpose. For example, gold and silver, they are used in jewelry. The main reason for that is that they don't react with air and water at room temperature, and they are also malleable, so they can be hammered into shapes. When we look at copper, we usually use copper in electric wires, and the main reason for that is that because copper are really good conductors of electricity and they are ductile, so they can simply be shaped into wires. Iron, it's too soft to be used as a metal alone. So we don't usually use iron as a metal alone, but they are usually mixed with a small amount of other elements to make steel. Steel is much harder than iron because iron is very soft and it's much stronger. Um, and also it can easily be shaped, so we can use the steel in different um, we can use it in different ways. However, iron and steel react slowly with water and air to produce rust. So this is a problem of the iron. Even though iron is not as reactive as group 1 elements, but it still reacts with air and with water to form rust, but this takes a long time. This is why iron must be protected from air and from water, for example, by a layer of paint. Chromium and iron